So a few of you were asking about graphing sine and cosine and also asking about domain and range. And so I wanted to do a video about those. And just remember that all of these values, when you're drawing a graph, all of these values come from our good friend, the unit circle, where we have the cosine value being the x coordinate and the sine value being the y coordinate. Really all I need are the first couple, excuse me, I want to get rid of that last little bit. All I really need are the first few of there we go, the first couple of the coordinates. So 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. I'm going to use radians in this video. So we have 0, pi over 2, pi, and 3 pi over 2, coming back home with 2 pi. So if I'm trying to graph sine, if I'm trying to graph y equals the sine of x, I'm looking at a graph, I'll center it here, where my first sine value, my first y value is 0, goes up to a y value of 1, goes back to a y value of 0, goes to a y value of negative 1, goes back to a y value of 0. This right here is called one period because it has done the cycle once. But it continues on, it continues backwards infinitely many times. Because your graph continues to the left and to the right an infinite distance, we can talk about the domain being endless. It never stops going to the left and it never stops going to the right. So we say negative infinity to infinity. However, I want you to notice what the highest and the lowest values are. It never goes above 1 and it never goes below negative 1. So when we talk about the range, we include negative 1 and then 1 with the brackets. That just means that your sine wave does touch those values, but it never goes above 1 and it never goes below negative 1. Okay, so what I'm going to do is now label the different x values here, just based on those radians. So this point here has an x value of pi over 2. This has an x value of pi. This has an x value of 3 pi over 2. And that one has an x value of 2 pi. All I really need are those 5 points, and I'm able to draw any graph. So in just a second, I'll show you a transformed graph, and we'll talk about the domain and the range of that transformed graph. So let's look here at y equals 3 cosine of 4x minus 1. So when I draw this graph here, I'm going back to the unit circle, and the difference between sine and cosine is as you start on the unit circle, your cosine value starts with 1, then it goes to 0, then it goes to negative 1, and then it goes back to 0. So that's a negative 1 there. Okay. And so if I try to draw the cosine value, my first cosine value would be 1. However, we've stretched it by a factor of 3, and we've taken away 1. So 1 times 3 makes it 3. Subtract 1 makes it 2. That's my initial value. Then what happens to cosine? It goes back to 0, but everything is times 3 minus 1. 0 times 3 minus 1 ends up here at negative 1. Then we're going to go 3 steps below that. How do I know it's 3 steps below that? Because cosine reaches negative 1. Negative 1 times 3 minus 1. Then we're going to come back to the midline. Then we're going to finish up back here. So this is one full period of cosine. Not my best drawing, but that's okay. And it continues the same way on the left side. Just like before, we have a graph that never stops going left and right. So it has a domain of negative infinity to infinity. I use the parentheses because you can't reach infinity. The range, the lowest value on the range, if you just count down, the lowest value on the range is negative 4, and the highest value on the range is 2. You can get that just by looking at the equation. Your midline is negative 1, so you go 3 steps above negative 1, and you go 3 steps below negative 1. That's how you get your range. Negative 1 plus 3 is 2, negative 1 minus 3 is negative 4. Now, the last thing I kind of just cheated with is I didn't even worry about the 4x, but what does the 4 do? That's a frequency. The frequency means that we actually do 4 cycles within 2 pi. It's going 4 times as fast. So normally this would be pi over 2, but we are going 4 times as fast. So instead of pi over 2, I have pi over 8. Normally this would be an angle of pi, but we're going 4 times as fast. Normally this would be an angle of 3 pi over 2, but we're going 4 times as fast. 3 pi over 8. And normally this would be an angle of 2 pi, but we are going 4 times as fast. So 2 pi over 4, or you can label it as pi over 2. Again, you can really get away by using just those 5 points and then scaling it by the frequency. The frequency, the number you're multiplying by, makes it narrower by that many times. And then conversely, if it's smaller than 1, that widens it out. And that's it.